bear with me. I'm going to try to move fast. If I'm moving too fast, too slow, let me know. Feel free. So what is 3D printing? A lot of my friends talk to me all the time, and they're like, hey, what is 3D printing? Does it print out paper, or what does it really do? I have no idea what it does. I hear about it all the time. I see it on the media, and it's supposed to do some really amazing things, but this concept is kind of hard to grasp. And I basically tell them it's a machine that can take your design and turn it into life, and it turns into a three-dimensional object that you can touch and feel and potentially use it, or some sort of consumption involved. And it's also a new type of digital fabrication. Now, digital fabrication is not something new. It's been around for a very long time. Can I get some hands? Anybody that are familiar with manufacturing at all? At all? We got one over there, awesome, right here. So digital fabrication has been around for quite some time. So let's take a step back and talk about digital fabrication. What does it really mean? Traditionally, fabrication is like, you build it by hands, or do things and make products by hands and build things, right? With digital fabrication, you're able to turn your concepts into a digital format. That's a 3D model with computer software. And then from there, you turn it into numeric coordinates with a set of instructions at each specific coordinate that you do. And basically, to give you a bigger picture, or a clearer picture, because it's hard to understand, I'm talking very high level here, CNC milling and laser cutting are two types of digital fabrication technologies. What it does is at certain coordinates with a block or a piece of raw material, it starts cutting away and shaving away and carve it into the shape that we actually envision it on the digital design. Now, 3D printing is actually not that much different conceptually. It also turns a 3D model into a set of numeric coordinates, and also with a set of instructions to do at each coordinate. But the big difference, and why it's such an amazing, revolutionary technology, is that while all the laser cutters and CNC routers, millers, they're cutting away, which is subtractive manufacturing. So you have a block of material, you're cutting, 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 cutting. 3D printing actually is an additive manufacturing technology, where it puts material and builds layer upon layer until it becomes an object. When I'm talking about this, you're probably like, well, so how is that cool? How is that interesting? Let's take a look at that picture over there with the two objects that are very complex, with a lot of inner shapes and inner details. With traditional digital fabrication technologies, it's practically impossible to do it unless you cut each piece at a time. For example, the letters over there. I cut out the letters each a piece at a time, and I have a bunch of people putting that piece of object together, which takes a lot of time, and it's not cost efficient. And do we hear some noise over there? Sorry. It's not very cost efficient, and that's why additive manufacturing is really cool, because 3D printing is able to, at each coordinate, add pieces at a time, where it's able to build that object in a whole all by itself. And what it has done, what it really means to us is that traditionally, prototyping, before we talk about mass manufacturing, prototyping is something that's very costly. It could cost $10,000+ in a week worth of time, at least, to get a prototype of my concept. I design something, I hire and outsource somebody that I don't really have much control over. It costs me an arm and a leg, and then they give me a prototype maybe a week later at best situation. Now with 3D printing, what we're able to do is that we're able to do this in-house with 1/10 of the time. So what I'm able to do is now put the 3D model in, get it ready, press a button, 3D print it out, and now I have a prototype for maybe at most a few $1,000s and a day's worth of time. So it's cost saving. That's what makes this technology so interesting and so amazing, and how much it's changed the design industry. So what 3D printing, with the cost going down, what it did is that I'm able to keep on prototyping very quickly, very cost efficiently, and actually gain a lot of customer feedback in turn, which has been, actually the iterative design is a method, that's a proven method that has increased the quality of design all over, be it if it's a 3D or a hardware piece, or even in software or anything else. So, this is why a lot of people have been coining this technology as the driving force into the third industrial revolution, because it's changing the way we think about things. We no longer have to deal with things like mass manufacturing, where they're like, well, it's really expensive to make a mold, so unless you're going to give me 100,000 units, I'm not going to do it for you. We can actually make things that's one piece at a time, or even low volume things. And it changes the way we do design, it changes the way we think about how we consume as well. Because there are consumers that are making things that are day-to-day, like I love playing golf. So I have a lot of accessories that are 3D printed and custom fitted for myself. I love coffee, I have a siphon at home, and I don't want to waste the coffee grinds. I use it as a silly deodorizer. So I have a fitted cup that goes into my siphon, which all the grinds dumps out, and I throw it in my toilet for a deodorizing experience, so to say. So it definitely has changed the way we think about things. And because it's so amazing, everybody has been starting to adopt this technology. A lot of people ask me, so who really uses 3D printing? I mean, it seems pretty crazy. Well, actually, a lot of people. Be it in conventional design for decoration or furniture, even a bike that you can ride, fashion, and edible goods for wedding favors, as well as, probably you guys heard, in China they're building houses with 3D printing. Of course, we can't forget, you know, consumer electronic parts, the casing of it, the design, the outer look, as well as novelty consumer items like making a mini-me of myself, or, you know, my wife gets a scan of the baby, she's pregnant, and now we have a model of our baby just for kind of, for memories. Why not, right? A lot of people are actually doing it all over the place.
Oh my God.
Yeah. So it does things that are improving our lives, but it doesn't only just improve our lives, it's actually saving our lives as well. In 2002, they made the first 3D printed kidney that was actually working in the human body. So now, think about this. In an emergency, I have an issue with one of my organs, and I have no donor. All of a sudden, I'm basically, you know, stand still until there's a donor, right? Well, with 3D printing and with bioprinting continuing to advance, that's no longer a problem. I need a kidney, we 3D print one, get the surgery done, problem fixed, problem solved, right? So, as well as dental, I had a friend that was having a cup of coffee with me the other day, and he's like, you know, I had the most amazing experience. I took my daughter to Europe, and they were saying that, you know, the dentists there are much better or something. So I go there, take a look, and I guess she needed a crown to replace her tooth, and the dentist told me to take a walk for 2 hours. 2 hours later, I walked back into the dentist's office. My daughter's crown was ready and just popped it right in her mouth. It was like, whoa, what just happened? So it's definitely what, you know, what used to be dentists had to take forever and ever and ever just to, you know, get things ready for you, but now it's just a matter of a couple of hours.
But that crown is milled, it's not printed.
Depends. Depends.
You can print a model, you can't print a crown, can't do it.
You can't do it? Oh, okay, well, that's what I was told, so.
It's milled.
It's milled, yeah. Well, there's a couple of 3D printing companies that are claiming to be able to do that. I don't know. I'm not an expert in the dental space, but this is the trend setting that I've heard.
Yeah, probably. No, they're doing it.
So it's also evolved quite a bit, and it used to be large machines where architectural offices that are sharing, you know, and fighting for a place to use the 3D printer. And slowly, just like how technology has evolved for us with computers. I remember mainframes, I'm not supposed to, and that are shared by multiple users on terminals, and then it slowly turned to personal computers, 286, 386, Apples, and stuff like that. Now we have laptops and mobile devices that are actually more powerful than computers that are 10 years or 20 years old. So just like 3D printing, all this technology is slowly going towards this, you know, the smaller, even it's a small package, but it's still getting more and more powerful, and it's making it more available where each and every designer's desk can have a 3D printer. I actually walked into an architecture firm, I forgot the name, probably about a year ago, where there's a designer's department and every single one of them had a 3D printer on it. And it was readily available where they're like, I don't have to fight for it. I think of a concept, I create it, and then I press a button and it comes out, and all of a sudden I'm able to collaborate with people and talk to people, discuss it, and make things better. And materials are pretty cool too, which I'll talk a little bit about. That was, if I could take a step back right here. That machine right here on the bottom, it's kind of small. That's a carbon fiber 3D printer coming from an MIT spin-off company. And then the one on the left, it's actually a fairly new machine. It's a true color, handles hundreds of different materials, and prints out in almost like final product shape. So I'm talking a lot about concepts and conceptually how 3D printing works. So what I wanted to do is bring you guys a quick video about actual application. This is coming from a company called Zboard. They made a motion sensing skateboard where when you lean forward it just moves and it's electric. There are two college students, which is why 3D printing and all the other platforms for crowdfunding have made such a difference in our world. You don't need a lot of money, you don't have to be very powerful, and you can still make a product and still make a company. And here we go. Check it out.
Zboard is an electric skateboard that's controlled entirely by your body weight. So no remote controls and no pushing necessary.
Because you lean forward to go forward, lean back to go backwards. So.
Kickstarter in spring of 2012.
And now we're about a year and a half after that Kickstarter project. We've now fulfilled all those Kickstarter orders and we're shipping and selling from our website.
We've prototyped a number of different parts. Several of our molds, actually parts that are in production right now, were designed on MakerBot. I have a background in SolidWorks, so I can draw the design, import it into our replicator too, and print it out that same day, find out whether it works or not, make changes to it, and print out the next version of it before the end of the day. It's just something that we couldn't ever have done before at a price per part that prints out that's pennies on the dollar of other methods. And particularly desktop 3D printers, like the products that MakerBot offers, are certainly changing the way that manufacturers.
These are the 4 limitations, and sorry, I should have made the words a little bit bigger. Pricing, quality, speed, and usability. I'm going to explain and expand on it a little bit more. Pricing right now, like I was telling people, there's printers that are a few $1,000s that are mainland China manufactured. There are also American and European brands that are around the 10 to 20,000 Hong Kong dollars range, as well as all the way up to Stratasys machines that are 4 million Hong Kong dollars a piece. From a corporate perspective or a business perspective, it's actually not that expensive. But for a consumer, unless I'm okay with the quality of the lower end 3D printing, it's still quite a bit expensive for everyone to have. Because if we go look at a computer mall or something like that, the 2D printers are just a few $1,000s, and they're great because they do exactly what we want to do. And it's no longer dot matrix, no longer what it used to be where it took a long time to print something full color, right? So, as well as quality. Quality, if you guys were, we have a table over there with objects, and you guys can take a look a bit later, but there's lines and layers specifically to the technology that we use, and that's probably subject for improvement. And there are people that are working on improving the quality of it, because there are people that come to our showroom and they're like, wow, there's a lot of lines. Can we get rid of those lines? Yes, we can, but there's a considerable amount of after finishing that we do in order to make it look like a very fine object. So. I think the quality needs to happen right out of the machine rather than us doing, with our hands to do the finishing. Speed-wise, it's great. It already beats out whatever we do in the business world, because you're dealing with less people and less points of failure. And now we're able to do that in a very quick manner. But to a consumer, instant gratification has always been something that's huge, right? If I press a button, I don't want to sit there and wait 5 hours for something to come out, right? And right now, it's still it's still sort of that way, and that's why people are working on these things. Usability-wise software, not everybody's an engineer, not everybody's a 3D modeler, so it would be very hard for everybody at their homes to actually learn how to draw in CAD. So I'm going to talk a little bit about development of things that are happening right now that are actually going towards solving these problems. There's a company out of California, a chemistry professor is the CEO of this company, and they have developed a technology that is supposed to do 25 to 100 times faster than the traditional 3D printing technology. They have a big automobile company testing it right now. So these are the strides that people are constantly working on, and it's all focused on all those 4 things that I talked about earlier. Software-wise, there are companies that are making consumer strides in software where I'm able to use an iPad and actually, which we'll try to do a demo here in a little bit, and twist the shape or do things, special things, simple things, and make a customized piece for myself and 3D print it out, as well as a bunch of community, designer community websites where you can download and edit, and also a lot of software that's supposed to be much more user-friendly, where kindergartners are actually being engaged in 3D printing technology now. Scanning, lastly, that's also a huge one. We have Harvey standing over there. He went to one of our partners' tailor shop, and he has a scanner that basically scans you in 2 seconds. It just goes zoom, and then he printed himself out, basically. So, of course, it's a very expensive machine, and that's why we're partnering with them, because equipment does cost a lot of money, and right now scanning is considerably high in price. So as the pricing goes down for scanners, and the more accurate they get with scanning, I feel like at the end of the day, when I had the slide earlier, it's a little chart with equilibrium. When all of those things come merging into the middle, with people more knowledgeable about 3D printing and technologies, I believe that's the time where it's going to be much more popular in everyone's homes. But whether that's going to happen anytime soon, that's that depends on all these companies that are working very hard to help us get there. But if it does, all these beautiful things that we see on screen will be made by you and me without any specific design training and things like that, and we're going to be completely thinking about making things and consuming completely different. So, and that is also why this last slide I just kind of had to put in there, is because even we're not quite at the mass population and of 3D printing usage, it's right in between where it's starting a big revolution in making things yourself, designing things yourself, and that's why there's a huge maker movement around the world, US, Europe, everywhere, even in Hong Kong, with some big organizations backing this movement, and starting to do things to help facilitate everyone to make things like we're doing as well, which is something that we'd like to do. So that's about it for us. I think that's about time. And what we're going to do is give a live demo of how this stuff actually works. So I'm going to pass this on.
Let me do the questions first.
Oh, sure.
So we're going to go into Q&As. Does anybody have a question? And wait a minute, do we have another mic? We don't. So you're going to have to call it out. Yeah.
Can you just talk about materials? What can you make? What materials are available to make these things?
Sure. So obviously plastic is very huge in 3D printing, and especially for the smaller machines. That's primarily what it does. And when you work with other materials that seemingly are different types of materials, they're actually composites. So it's about 70% plastic, and then 30% of some sort of metal or wood or something like that. But if you're looking at bigger machines and the more expensive, the higher grade 3D printers, there's pretty much a 3D printer for every single material you can think of. That's why they're building houses with it, and they're able to do metal, they're able to do carbon fiber like I mentioned earlier. And it uses different types of technologies, which I've listed, and I don't think we have time to cover it, but there's different types of 3D printing technologies that are more fitted for different types of materials. Does that answer your question?
Sorry. Any more questions? Eric?
I'm just wondering, I mean, you talk about people having them in the home. I mean, a 2D printer, I mean, it prints out, I mean, every day of the week you want to print out whatever from your computer, but apart from being a kind of Christmas novelty and printing out some plastic kids' toys, actually on a daily basis, what would you use that for at home?
You know, to me personally, don't quote me on this now. To me personally, I think even a 2D printer at home, not everybody uses it every day. I'm not expecting 3D printers to be like computers, where we're using it on a daily basis. But it could be a very nice accessory at home for parents to engage with children, or to do home improvement, or to make things you know, once in a while that's related to your hobby, right? So for example, I have a friend that's into biking, and he's always making these accessories for his bikes and things like that. But is he using the 3D printer every day? No, not necessarily. Even I personally don't use the 3D printer every day. My staff does, but I don't. So, yeah, does that answer your question? Sure. So the question was, what sort of skill sets you need in order to...
Because the hardware is always so expensive, probably $5,000, $10,000, $20,000. But if you really want to manage it, what other elements you need to
Yeah, to fully utilize a 3D printer, you'd probably be, right now at this point, you have to be very well versed in CAD drawing, 3D modeling. So any CAD software out there right now, at least 90-something% of them can export into a format that's readable by our software, which is a slicer. And then they'll turn that 3D model into numeric coordinates, like I mentioned earlier, where the printer knows what to do and starts printing.
Okay, thanks.
Yeah.
Any more questions before we go to demo? Oh.
Yeah.
Just as we have trouble with our 2D printing, and printers are very cheap, but the ink cartridges are very expensive. What about the media itself? The plastic, the wood, the metal,
Right.
and maintaining it.
Right.
You have to maintain the printing media,
Sure.
just like you have to keep ink from drying out.
Yep.
That seems to me like the biggest challenge.
Right.
Rather than how fast something prints or how well you can control it, it's actually the raw product that, to me, is a bigger hurdle in technology.
Right. There are also a lot of third-party, I'm probably not supposed to say this, there are a lot of third-party manufacturers that are designing the exact type of filament that are made for these machines that are even cheaper than the official manufacturer. Of course, I'd have to say each manufacturer always tells us, we designed our filament for our printer, just like how HP says you shouldn't buy the third-party ink, right? So, but it's not as expensive as you think, and that's actually one of our mottos, is that we want to make sure that consumables are affordable, so that it encourages more adoption. So you can buy each roll in a different type of color in this particular machine, you can also buy third-party composite materials, like we've made wood-like objects, we have made metal-like objects, and supposedly glass-like, which I don't feel like it's very similar to glass. Yeah.
Can you give a quick example? How much are these two machines?
Yeah, sure. This one is, should we talk US dollars?
Yeah. Lower numbers.
Hong Kong dollars.
Hong Kong dollars. Okay, so this one is 25,000 Hong Kong. That one over there is 19.
As a Thingiverse website, you can search all sorts of models. There's the models come in month, which is the most famous ones. You can download, either you can download the model and modify it for yourself. So for this demonstration, I'm just going to search on one of the models.
Yep, so it's all connected by Wi-Fi, and we also have a camera over here monitoring. You can actually walk the streets with your iPhone and still monitor the progress of the prints, because these things do take a little bit of time, and sometimes things do happen, and you want to be able to pause it when it's gone wrong. But it's going to basically print out this object right here that was automatically generated from just taking a picture from that piece of paper.
Have a good evening.
Thank you, guys.
Is the output that's trying to damage is something?